In this video, I'm going to show you how to create an empirical distribution function. And we're going to begin with this very simple example that we're looking at. You recall the Vibrio parahemolyticus and oyster risk assessment, perhaps, and one of the inputs to that risk assessment was water temperature. So imagine these are the data points that we have. In column B, we have the water temperatures, and in column C, we have their cumulative distribution probabilities. So what we're going to do is take those 5 sets of numbers, x values and probability values, and we're going to create a probability distribution. So I'm going to put my cursor right here in cell E7. I'll select the at-risk tab. We'll go to the model cluster, and I'm going to choose define distributions, and I want the cumulative distribution. When it comes up, I'm now going to type in the values that I would like to use. The minimum temperature is 23. The maximum water temperature is 35. The other x values, I get rid of the default values and I type them in. 27.9, 29, and 29.8. And I close the curly brackets. Now I go to the probability table and I begin with the corresponding probabilities. 0.26, 0.5, and 0.75. And I close the curly brackets. I'm not a very proficient typist. But here you would see the probability distribution. If I switch the view by doing a right mouse click on the graph and choosing graph options and say give me the cumulative ascending, it shows a cumulative distribution function representing the relatively limited data I have. I click OK, and now what I have is a distribution here in this cell that can interpolate values between a probability of 0 and a probability of 1. To do that, you turn on the Monte Carlo process here, but you would need to know that when I'm using this video software, it doesn't work well with at-risk. By that I mean turning on the dice icon. I can't use F9 the way you can. So when I click here, you'll see it reverts to 28.89. It gives me another number, goes back to the expected value, gives me a new number, expected value, new number, and so on. Once I turn off the video software, things work fine. But here's the idea. I can take this cell right here. I can copy it. And I can go to a new cell anywhere. And imagine that I am pasting that into my risk assessment model. Now if I pull up define distributions, I have the very same distribution that we just created. So that makes the cumulative distribution function a powerful tool. But how often do you have data like these? More often than not, what you're going to have will be data that looks like this. Water temperature data, where I have, in this case, for our example, I've got 100 data points. So what we want to do is create a cumulative distribution function from these 100 data points. The first thing I need to do is to sort my data. And I've already gone ahead and done that for you. If I had not, the way you sort data is you click on your data, select the Data tab, hit the sort from smallest to largest, and bingo, you've got it. So that's what I have already done in my rehearsal here. Now I need to bound my data. This is a piece that I didn't explain in the initial distribution, and that is to say if I have 100 data points and I believe my data are extensive, I've got a good number of data points. They're representative of the population I'm interested in, which is water temperatures in the summertime in the Gulf of Mexico. But I need to consider, if I only have 100 data points that I'm using for this example, have I indeed captured the minimum temperature? And I am going to conclude that I have not. So I'm going to insert a row here. And in here I'll put my minimum. That's the 23 that you saw previously in the last example. I need to also bound the upper limit. And so I come on down here and I'm going to put in a 35 degrees. Now I've not researched that. I'm just using those numbers as examples for this particular exercise. But now I have an array of data from a minimum to a maximum. What I need to do now is to figure out the probabilities. To do that, I begin by numbering the data. So I number the first two, and then I just copy this sequence all the way down, so that now my data are numbered from 0 to 101. Now I need to create cumulative probabilities. The way I do that is I type an equal sign, and I say take this value, and it's important to begin at 0, and divide it by the total number of data points. In this case, 101. It could be 1,000,000, it could be any number. Now I'd like to copy this formula, and that's also simple to do. So I've now generated what amount to being percentiles. This is the cumulative distribution. And what it's telling us is this. The probability that the temperature will be 35 or less is 100%. I'm absolutely sure, as long as I have properly identified the maximum, that the temperature will be that or less. Let's take a look at the probability that the temperature will be 30 degrees or less. That probability is 77%. And so for every temperature observed, we have an estimate of the probability that it will be that or less. And of course, there's no chance that the temperature will be below 23 degrees. So now we're going to use this information and create a cumulative distribution. Once again, to the at-risk tab, to the defined distributions, to the cumulative distribution. It would be tedious to type in all the numbers the way I did, especially the way I type, with 100 data points. So I'm going to use the Excel reference. I click here and it's asking me for the minimum, and I say that's the value in B2. The maximum, I scroll on down. That will be the value in B103. It's saying where are the X values? I do not use the minimum or the maximum here. I use all the values in between, and they are found in cells B3 through B102. Now I'm being asked for the probabilities of those values. That's what we just created. So I am scrolling down, selecting that, closing my reference cell, and now you see that cumulative distribution that was 4 line segments or so in the first version is now smoothed out considerably. And if I click OK, now in this distribution here, I have embodied all of the information in my data, and that is the empirical distribution that I would use. Remember, I have that problem with my spreadsheet and the video software, so I have to continuously keep clicking on the dice, and every second value is the same. It's the expected value. But I do have the ability to generate randomly any number of values from my data set here. The difficulty comes in if I would like to copy this and move it. If you look in the formula cell, it's referenced to these data. So if I were to copy this distribution here, if I copy this and I move to another spreadsheet and paste it, I have a problem because the data that are being referenced are missing. So we have this neat tool that can take 1,000,000 data points and reduce it to a single cell. But to copy and paste, you have to use a little bit of trickery. Here is the trickery. Notice that over here I use selected data points, basically the first, second, and third, fourth quartile values. So you can use percentiles if you like. You could say, let me use the 0 percentile, 10%. You could use those numbers. For 20%, you would use these, and so on. For 30%, we could grab these numbers. So I could grab 10 numbers from this spreadsheet and create the distribution using 10 numbers. What I've done for this example is I basically went and used the percentiles. So I said, let's use this number right here. Actually, this number right here, the 25th percentile, and copied that to the previous sheet. I scrolled on down. I got the 50th percentile right here and copied that. I grabbed the 75th percentile, copied that, and pasted them all into here. So these numbers that you're looking at here, these are a subset of these. So if you have 1,000,000 data points and you want to create an empirical distribution, you would grab a subset of your 1,000,000 numbers, copy them like this. You would use more than the quartiles. You could use deciles, the 10th percentile, the 20th, the 30th. You could go every 5th percentile, 0, 5, 10, 15, 20. Or if it was important, you could use the percentiles, 1, 2, 3, 4, 5. It would be tedious to have to type in the actual numbers. If you were using percentiles, to type in 100 x values or 100 probability values would indeed be tedious, but it is doable, and it would enable you to capture all the information in your data and embody it in a single cell that can be copied to any risk assessment spreadsheet anywhere. So if you have questions about this, please feel free to ask in class.